Welcome back to the ICND1 series, and in this video we'll be looking at layer 2 protocols. So the layer 2 protocols we're going to cover in this video, well over the next two videos, are going to be CDP and LLDP. Now these layer 2 protocols allow Cisco devices to collect information about each other and about neighboring devices. So the way it works is that with these protocols, imagine we have two switches with a trunk connection. We have switch 1 and switch 2. CDP and LLDP allow these two devices to exchange info, so that in this case switch 1 knows about which devices are connected to it. In this case it'll know that switch 2 connects to it, and it will know what type of device switch 2 is. So it'll know that switch 2 is a switch. It'll know the interface, its own interface that it can use to reach that device, as well as the interface on switch 2 that connects to switch 1, and other info about the device, like the device host name. And the good thing about these protocols, they allow us to build a network topology diagram on the fly. So these devices allow these protocols allow a device to discover the devices that connect to it. And so what we can do by issuing a few show commands, we can begin to build a picture of what devices connect to each of our devices and build a diagram on the flow. So in this case we may see that switch connects to this router, and then when we go to the switch we may see 3 or 4 devices. Maybe there's a wireless access point over here which connects to the switch, and another switch over here. So we're able to build a network topology diagram, our physical one as well as our logical topology diagram, by using these layer 2 protocols to see what devices connect to a single Cisco device. Now, in this video, we'll be focusing on CDP, so Cisco Discovery Protocol. And CDP is a protocol which is only used by Cisco devices. So CDP, it only runs on Cisco devices. Vendors such as HP and Juniper, they cannot use CDP. And with CDP, it allows Cisco devices to find information about other neighboring Cisco devices. So the way CDP works, imagine we have these two devices over here. CDP messages are sent every 60 seconds. So in this case, switch 1, switch 2. Every 60 seconds, switch 1 will send switch 2 a CDP message, as a CDP advertisement, which will contain information about switch 1. And when switch 2 receives that info, it's going to store that information for 180 seconds. It's going to cache that information in a table. The way it works, that each time switch 2 receives a packet for a CDP packet from switch 1, it's going to update that info in this table. If switch 2 for some reason doesn't receive a packet from switch 1 for 180 seconds, it's going to forget and remove that cached information from its table. So the way it works is that switch 1 will send CDP packets every 60 seconds, switch 2 will receive that cached information. The information will be stored in the table for 3 minutes by default. Every time switch 2 receives a packet from switch 1, is going to refresh that timer back to 180 seconds and refresh the information. And the same thing works both ways. So switch 2 will be sending switch 1 CDP packets every 60 seconds. The information is stored in the CDP table on switch 1 for 180 seconds. So with CDP, this cached information will be stored and will be refreshed every time a device receives a CDP packet. As CDP packets themselves are sent to the multicast address of 0100 0C CC. The reason why they're sent to a multicast address is so that only devices that need to process that packet will process it. So in this case, your Cisco devices, they will be listening on this multicast address, which means that so imagine this is our Cisco device, it's our switch which connects to a router, but we have a connection to a PC over here. In this case, CDP packets are sent to all interfaces by default, but this is our PC. Our PC will not process those CDP packets because it's not listening onto this multicast address. Our router over here will be, so when it receives the CDP packets, it's going to process them. But with our PC, it's not going to process those packets. It's still going to receive them though, but it's not going to process them because it's not listening on this multicast address for anything. And so by using multicast address, we can send one packet to many devices, making a more efficient use of bandwidth, instead of having to send a unicast packet to each and every device or broadcast packets to all devices. Now CDP runs between devices in the same network, and messages are never forwarded onto other devices. So in this case, if we had this kind of scenario Okay, CDP packets are sent over the local segments. So in this case, switch 1, switch 2, and router A. Switch 1 will send a CDP packet about itself to switch 2. Switch 2 will store that information, but it's not going to forward that CDP packet onto router A. The reason why, switch 1 isn't a neighbor of router A, so router A doesn't need to know that info. Switch 2 will send information about itself to router A, and router A will not forward that message on to another network. So CDP information stays within the same network, and messages are never forwarded on between devices. CDP sends information about the local device by using TLV fields. These are known as a type length value field. So the way it works is that within the CDP packet, it would be like a type attribute, maybe like device name or something like that, a length field which denotes the length of the attribute and the value. So in this case, if it's host name, it could be switch 1, or if the type field is like IP address, value could be 192.168.1.2. So CDP information is communicated using TLV fields, and we will see this later in the video where we do a Wireshark capture. And with CDP, a switch can listen to the messages and can use the messages to determine when the interface on a neighboring switch has gone down. The reason why, because it will stop receiving those packets, and we'll be able to tell, okay, the interface on this device has gone down because I'm no longer receiving packets from this device. Or maybe an interface has gone down because the device stops listing that interface in the CDP advertisement. Now CDP works on most interfaces are fast Ethernet serial interfaces, apart from multi-point sub interfaces. We'll talk about more about multi-point sub interfaces when we get into frame relay. And with CDP, the IP address the device uses in the CDP packet is normally the IP address of the interface it's sending the packet out of. Now in this case, if that IP address doesn't have a if the interface doesn't have an IP address, in this case, for some reason this interface doesn't have an IP address. If the interface doesn't have an IP address, then the device will use the IP address, the next available or the next highest IP address of the next available interface. So in this case, if this interface has an IP address, the router will use this IP address as the source IP address of its packets when it sends these packets to the switch over here. Or in this case, if it's a switch, it normally uses the VLAN interface IP address as the IP address of the CDP packet. Now there are two versions of CDP. They are CDP versions 1 and 2. CDP version 2 is enabled by default on most Cisco devices, and it has more features than CDP version 1. So with CDP version 2, it provides better device tracking features, and this includes an error reporting mechanism that reduces downtime. The way it works is that with CDP version 2, imagine CDP version 2 is running between these two devices. Okay, if any errors happen between these two devices, CDP can detect the error and inform and generate a system message on the device. So in this case, imagine that the native VLANs are mismatched between these two devices. Well, then what will happen is that CDP will actually issue a system message on the switch to alert the person, to alert the console person, so the person who's using the switch, that a native VLAN mismatch is occurring, or maybe the speed configured on each interface is mismatched, or maybe the duplex is mismatched. Again, the CDP will pick this up and will issue a system message. Now with CDP version 2, it can also be used to exchange information that CDP version 1 can't. Mainly, CDP version 2 can exchange the VTP domain name of the device, the native VLAN information of that interface, and the duplex information on that port. So the CDP version 1 cannot be used to exchange those three types of information between Cisco devices. And when we look at a CDP frame, and you can see that we have the destination address, which is this, the source address, which is going to be the MAC address of the device, and we have the time to live field, the checksum, and the list of TLVs. And the TLVs all have this format: type, length, and data. And so, as an example, maybe the type field could be addresses, port ID, capabilities, software version. So in this case, 0x0001 would note the addresses. Maybe 0x003 will know the capabilities of the device, so we can see what device it is. We have management address. So in this case, the TLV fields will, the type field would have one of these values to indicate what information about the device we want to exchange now. The data, the value would just be the information about that field. In the case VDP domain name, native VLAN or something. So now we're going to talk about configuring CDP. So by default, CDP is globally enabled on the switch for all interfaces, so we wouldn't have to do anything with CDP. It is recommended though that for interfaces that don't connect to another networking device, like another router, switch or firewall or wireless access point, to disable CDP for those devices, because it can cause a security vulnerability in your network. So in this case, imagine we have this kind of scenario where we have a PC over here. By default, CDP messages will still be sent out to this PC, okay, which isn't really needed because a PC exists on the other end of the device. It doesn't understand CDP, so it's not going to send CDP information back. However, an attacker could exploit this and could remove this device and attach another switch. Now he's able to gain information about this switch, about your network, and able to configure his device to meet the same configuration of this trusted of your switch over here. He's able to join the switch to your network and introduce rogue devices, or he's able to capture packets that will flow through it. Now we can change the frequency at which CDP packets are sent by using the CDP timer command. So in this case, normally CDP packets are sent every 60 seconds. We can change this to a different frequency, maybe every 20 seconds or 30 seconds. We can also change how long the device will cache this information in its table. We'll hold the information in its table by using the CDP hold time seconds command. And we can tell the switch to either send CDP version 2 or version 1 advertisements by using the CDP advertise-v2 command. Now by default, CDP version 2 is enabled by default, so all advertisements sent by CDP will be version 2 advertisements. Now we can enable or disable CDP globally on the switch, so enable and disable CDP on all interfaces on the switch by using the CDP run command. If we use the no CDP run, that will disable CDP globally on the switch. And we can enable and disable CDP on a per interface basis by using the no CDP enable command. So CDP enable turns on a per interface basis, no CDP enable will disable it on a per interface basis. So now let's actually go to the console line of a device and see CDP in action. So see how we can configure the different options for CDP, and see the different show commands that we can use to find out information gained by CDP. Welcome back to the ICD1 series. So we have a console connection now to a switch, and so what I've got set up now is I have a switch with a connection to a router. The router's on the end of this link. Port fast Ethernet 0/2 connects to the router, and port fast Ethernet 0/0 connects from the router to the switch. Okay, so to see all your CDP neighbors, we can use the command show CDP neighbors. This shows all of our device's neighbors, as well as the interface the local device can use to reach that neighbor. Now the port ID here listed lists the interface on the neighboring device that is used to connect back to the local device. So I remember I said before that, so it measures our switch. This is our router over here. Our router connects to our switch via port fast Ethernet 0/0. That's why it's listed as a port ID here, because that's the port our neighboring device uses to reach us. The local interface is the interface that we use to reach our neighboring device. The hold time defines how long this information is being cached for. So in this case, it's 124 seconds, 122, 121, 120, and now it should go back to 180 because we're receiving CDP packets from that router. This is the host name of the device, and the capabilities, these are codes, so routing, something else, and we'll get into those when we look at an in-depth look at the CDP information. And the platform, so this identifies the platform of the device. In this case, there's a 2620XM router. Okay, so CDP neighbors gives us a nice overview of our neighboring devices, so it tells us of all of our neighboring devices and what interface we can use to reach that neighboring device. So to get a more detailed look into the actual information about the device, we can use the show CDP entry command. In this case, we can list all entries, or we can look at a specific device. In case we'd reference the device by its host name, which is case sensitive. This shows us all the information that we know about this device called a router. It tells us the IP address, the platform, the capabilities to connect to the router, switch, and IGMP. There's the interface we can use to reach it, and the interface it can use to reach us. the whole time. Also tells us the version of iOS, of software that it's running, as well as the VTP advertisement version, the VTP domain name, the duplex, and any management addresses we have. So there's a lot of good information about that device. In this case, if you show CDP entry and you start, if we had more than one CDP neighbor, it will list information about all those neighbors. So in case it might start with this device called router, then it mentioned we had another device called switch, it would list information about that device as well. CDP commands. We can use the interface command, which lists in this case FA062, which lists information about this interface. So it lists whether CDP is enabled on the interface, how often packets are being sent, and the hold time for the interface as well. We can also use the show CDP traffic command. So there's the number of CD packets being sent, the number of CD packets received. And we can also use the show CDP command, as this just tells us whether CDP is enabled globally on the switch and the global hold time value as well, and whether the sending of CDP version 2 advertisements is enabled. So now to configure any features with CDP, most of them are configured from the global configure mode, so we have to move from privileged exec mode into global configuration mode with the configure terminal command. And so we can disable CDP globally on the switch with the no CDP run command. If we enter this, if I go to the show CDP neighbors, nothing will be listed, and you can see CDP is not enabled. So to enable again, I can use CDP run. To change how often CDP packets are sent, we can use the CDP timer command. In case I change it to 10 seconds. And to change the hold time timer, we can use the CDP hold time command. In this case, I'm going to change this to 100 seconds. So if I go back to show CDP, it tells us that CDP packets are sent every 10 seconds, and this information is cached for the information we receive. Any CDP information we receive from neighboring devices is cached for 100 seconds. Terminal. CDP and more commands, and then to enable sending of version 2 advertisements, we can use a CDP advertise -v2 command. Now to enable or disable CDP on a per interface level, we have to first go into that interface. In this case, I'm going into interface fast instance 0/1 because that is the interface which connects to my laptop, and I'm going to issue the no CDP enable command. This enables and disables CDP on a per interface basis. Okay, if we go back to show CDP interface FA0/1, as you can see, it doesn't list anything on the interface because CDP is not enabled under this interface. It lists if interface FA0/2 and FA0/3. And again, to enable CDP, I have to go back under the interface level and issue the CDP enable command. So now CDP is enabled back on the interface. And if I could do a show CDP interface FA0/1 command again, it shows the CDP is now enabled again. Now what I'm going to do now, I'm going to pause the video. I'm going to get a Wireshark capture of a CDP packet that's being sent from switch 1 to the router, and then we're going to analyze that packet and see how the CDP packet is sent, see what a CDP advertisement looks like as it goes from switch 1 to the router. So welcome back. So I've captured a CDP packet as it's flown. So in this case, I caught one which was sent out of fast Ethernet 0/1 back to my laptop, and so we can examine the contents of it. As you can see, so the CDP packet, it lists the device ID, which is the name of the device, software version. I'll move it up a tiny bit. We can see things like the port ID, so the port on the switch this packet was sent out of. We can see the capabilities of the switch as well. So in this case, whether it has routing capabilities, switching capabilities, IGMP capable, repeater, hosts, so on and so forth. We can see any addresses it has. So in this case, it has one address. This is its address over here. 192.168.1.1. It's an IP address. The platform of switch it is. So it's a 3560 8-port switch. Software version. So Cisco release the iOS version it's running and the release. We can see the protocol hello. We can see the VTP domain name. In this case, it's Cisco. The native VLAN, the duplex, untrusted, management addresses just so we can use to actually manage the switch. In this case, it's 192.168.1.1. So if we had multiple VLAN interfaces, it will list all these as management addresses and power available. So this is a switch which supports power of Ethernet, which means that it can actually be used to provide power to these devices. This will tell it whether it's actually giving power to this device, in the case it isn't. So we've reached the end of this video, and we have seen how CDP works. We've seen the fundamentals of CDP, how it's used by Cisco only devices to exchange information, and can help us when we're trying to build a topology diagram of our network. We've also seen how to enable CDP is enabled by default, how to disable it on a per interface and on a global scale, and we've seen the information shared within CDP, as well as how a CDP packet look like as it's going from source to destination. I hope this has been informative for you, and I would like to thank you for viewing.